Um, all right. Well, we made it pretty thoroughly quickly through announcements and the business part of the meeting this evening. So looks like we might get to kick off our main presentation a little bit early, which Howard, I guess I should probably hand it over to you to do the introduction for Tom here. Howard, take it away, please.
Okay, well, we have Tom Medlin, W5KUB, who's located in Collierville, Tennessee, and he's graciously agreed to talk to us about some of his projects, in particular the Pico Balloon project. And since I don't know a whole lot about that, I'll turn it over to Tom and let him give us a rundown on what he's got going. So over to you, Tom.
All right, thank you, Howard. And boy, hey, it's a pleasure to be with you guys tonight. I enjoyed your meeting tonight. I may have to join you guys. All right, well, I've talked to a few of your people there, and you guys have got a great club there. Hey, I was asked tonight to talk about Pico Balloons, and you know, it kind of falls into, first of all, I'll introduce myself and give you some stats on me here in a minute, but and then I'll mention this a little bit more toward the end of my talk tonight, but we have a ham radio show called Amateur Radio Roundtable, and it's a weekly show. It's been going now close to 7 years, and we've got great co-hosts, and we have guests from around the world. We have different things going on, and we've been having a project going called Pico Balloons. And I know some of you guys are going to be probably launching one here soon. So we want to talk a little about Pico, and then I'll close it off and tell you a little bit more about the show. And I think we've got some interesting things that many of your members might be, you know, interested in joining us. So let me kick it off here. So tonight I'm talking about ham radio going around the world at 45,000 feet. And by the way, we just launched a new Pico Balloon this afternoon at 1 o'clock this afternoon. It's already reached 42,500 feet, and that's the altitude that it's going to fly. And we hope it's up for 6, 7, 8, 9 months. We're not sure how long it's going to stay up, but last I looked at it, we were doing 132 miles per hour, and we were over Atlanta. So we're heading your way. That's me. I'm an extra class ham, been licensed since 1964. Not an old timer like some of you guys, but it feels like it's been a long time. But I can remember my first contact, and ham radio has been great to me over all these years. And it's just amazing at all the things that you can do in ham radio and stay interested in it. I've got a general radio telephone operator license with radar endorsement. That was the old first class license. Many of you may know. I'm a senior member of the IEEE and, of course, host of the popular video podcast called Amateur Radio Roundtable. So let's see. Let's talk a little about what's going to go, what we're going to talk about tonight. Pico ballooning. I wrote an article in CQ magazine last month. And so some of you guys, if you take CQ, you probably have already heard a lot of things I'm going to talk about. But we were in the October magazine of CQ. So, you know, dig it out and look it up. And if you need to refresh yourself on anything here. What is a Pico balloon? It's not a weather balloon. You know, weather balloons are real stretchy, big things. You put a lot of gas in them. They go up real high. They pop and they come back down. And that's how they're made to do it. They'll go up and they'll burst and fall. Our balloons are made not to burst. Well, let me go back. Our balloons, we engineer our balloons not to burst. In other words, we know the cubic feet inside the balloon. We know the weight of the payload we're going to send up with it. We know the lift of the certain gas, whether we use hydrogen or helium or whatever. And everything's calculated down to the gram, and we'll put just the right amount of gas, lift gas in it, that we can fly these balloons at, say, 42,000 or 45,000 feet. And they will stay at that altitude from that point forward. The one today is flying at 42. It hadn't quite reached its maximum altitude yet, but it's flying at 42,125 feet tonight. We're solar powered only. If you look at this little diagram here, you see the balloon at the top, and you notice it doesn't look like it's filled up very much. In fact, our balloons, when we launch them, they look almost empty. And that's because as gas expands, every 18,000 feet, the gas will double itself in volume. So we got to be careful there. We don't want it to expand larger than the balloon can hold, or it will burst and it will come down. So our typical configuration, like we're flying today, is the balloon, of course, and then we have a little tracker that we build. We're building our own tracker, and it's located at the end of a string. They're at about 17 feet below. Now, why is it 17 feet below? Well, we're using 20-meter whisper as the communications for this balloon. And we're flying a 20-meter dipole, a 20-meter vertical dipole. So half that antenna runs from the tracker up to the balloon, and the other half of the antenna hangs below the balloon. Now, probably many of you guys know what number 36 wire is. It's about the size of a hair on your head. You can't hardly see it, man. That is what the antenna is made out of. The entire 20-meter antenna weighs 1.6 grams. And that includes the string that goes from the tracker up to the balloon. 1.6 grams. A penny, a US penny, weighs 2.5 grams. So we've got a full 20-meter vertical dipole antenna that weighs 1.6 grams. Then, of course, we've got solar cells on there to give us power. And we are running solar cell only. We're not running batteries on these flights. The solar cells give us enough current, but there's a problem there. We can only transmit during sunlight. So anytime we're in the dark, we're not going to be transmitting. So only during daylight hours. Now you may ask, well, why don't you put a battery on it? Well, first of all, batteries are very heavy, and also second thing is a battery won't work at 45,000 feet. A rechargeable battery won't work up there. We're talking about temperatures of minus 40 degrees Celsius, which is about minus 95 degrees Fahrenheit. And I have a video that we put together here in our lab, and we show that we try to charge one of the little LiPo batteries, and we discharge the LiPo battery, and we bring it down. We bring the temperature down to minus 40 degrees, and the battery just turns off, just like it's not there. It won't charge, it won't output. So we don't run batteries at all on these things, but we got some great coverage with solar cells during the daylight hours. Of course, winter, we have less daylight, but we tried something new this time. We tried a different configuration of our solar cells. Normally we fly a flat panel pointing up, but you know, winter, the sun's low. And if the sun angle on the solar panels is not greater than 20 degrees, you don't get any voltage. Well, we're flying one today, the cells are tilted down, and we actually had maximum voltage from sunrise till sunset. In fact, we actually transmitted to 3 degrees below sunset tonight. So that was really exciting. We've never done that before. Let's see what else we got here. Oh, and I just threw a bunch of slides. Man, this is such an exciting thing for me to talk about. I've got hundreds and thousands of pictures here, and I just grabbed a bunch just to give you guys kind of an update of and kind of insight to what we're doing here. Hey, here's a balloon. This is my friend Ed Harrison here, and this is a typical launch. This looked exactly like the launch today. That is an SBS-13 balloon. You can fly. There's only a few balloons that are capable of flying in this float Pico balloon type environment. There's some very inexpensive $4 Chinese clear balloons that we can fly. They'll last maybe a week and a half, 2 weeks. Some people have flown them a lot longer, but typically they don't last that long. They fly at much lower altitudes. They won't fly much higher than about 38,000 feet. This particular balloon here is one that we fly on all of our flights. This is called an SBS-13. It's the only other option. It's made out of a material that actually they use nowadays to wrap sushi with. It's to keep the freshness in. So this is a sushi wrap balloon, basically. And and that is that membrane there will hold the hydrogen or helium inside where another balloon won't do it. And I know I've seen and bought these party balloons and take it home, to your kids, and, the balloons float, and then the next day they're on the floor. Well, our last good flight went 72 days, and it went 3.5 times around the Earth. You can see just a little bubble in the end because that balloon is going to expand as it goes up. Every 18,000 feet, that's going to double. So that's a launch there. We need calm with that balloon there. We need calm weather to launch. We had 11-mile-an-hour winds today, so we needed a long runway. And I think after probably maybe a few thousand feet, we were still only up about 340 feet after about 3,000 feet. But it finally hit the altitude and went on up. There's a number of different commercial trackers out there available. This is one by QRP Labs. It's a typical setup. You can see the solar panel is soldered on the side there. There's some supercapacitors in there. The supercapacitors are there to help steady the voltage. And for instance, that thing's going to be kind of moving around a little bit in the air, and if that solar panel gets out of the sun for a second, typically your voltage would go off. So those supercapacitors there will actually hold the voltage and the current there. On our flight today, they will actually run the tracker for 2 minutes. Even if you turn the sun off, it would still run for 2 minutes on just the super trackers. So that's a typical one by QRP Labs right there. Here's Bill Brown. Bill Brown has got a great tracker. He called it the Sky Tracker. You can see 2 solar panels on each side, and that's his tracker. The QRP tracker, it's probably it's a little over $100. I think Bill's is probably $150, $160. But it's already assembled, and Bill provides you a balloon. He provides you, he puts the code in, he puts your call in, he does everything. It's ready to fly. Here's in the left picture there is that QRP tracker that I showed you a few minutes ago. And if you look on my in the right picture, that's the tracker I'm flying. That's the tracker I'm building right now. It is that entire tracker only weighs 1.5 grams. That is lighter than a 1.6 gram antenna. So if you look at that tracker in my hand there, it's got a GPS system on it. It's got a computer processor on it. It's got a transmitter on it. And all that in that one little thing in my hand there, 1.5 grams. I have to build that under a microscope. The parts are so small, you just can't see them. And if you drop one, don't think about trying to pick it up. You're not going to find it. So there's a tracker that I'm flying right now on the left. There's Bill Brown's tracker on the right there, his Sky Tracker. His Sky Tracker is a great tracker. So there it is again, you can see it. The wires on there actually weigh almost as much as the tracker. So we don't use those wires, but just for testing, I had some wires on there to hook the antenna up and also to hook power up. We had a thing going with our show, our weekly show, that we were going to get a balloon around the world if it took launching one every week. And of course it could get expensive, $160 balloon, $150 tracker, talking, $300 a launch, not counting gas and stuff like that. So we had a commitment on our show that we were going to get a balloon around the world. And we have actually been flying a balloon solid for the past 12 months for the show. I decided that we were going to build our own tracker. That's the little boards I had made right there. I can build that little tracker for about $40, where if I bought one, it would cost me $150. So it saves us a little bit. Okay, so that's the tracker we're running right there. Here's a part. I want you to look at this really closely. I don't know how good the connection is there, but if you look on the end of the tweezers, you can see that is a resistor. That's a resistor on there, and I magnified it down at the bottom. Those are 0402 surface mount capacitors and resistors. And I built it under a microscope. That tweezer will hold it. It takes the smallest soldering iron you can find. and it's pretty tedious. I started building these things, and they were so difficult. I said, it can't be done. And I quit, I think 6 times, but I kept staying with it, and I finally mastered it, and I can build them now. So there's another shot of that capacitor. See, that is a sewing needle that you see there. It's not a baseball bat, but that's a sewing needle. And if you look right at the end of that sewing needle, that is like a 0.01 cap. So you can see the size there, and you can see, like I mentioned, if you drop one on the workbench, just don't even look for it, just get another one. There's a comparison of the tracker I built with a postage stamp. That's one of the solar cells below it. A friend of mine in Romania actually designed the tracker board, Edward, Y03ICT. And I want you to look at this picture on the left here. That is the tracker that I'm building. Plus, he has 6 solar cells on it. Plus, you see the little antenna sticking up there. That's the GPS antenna. His entire tracker, plus all the solar cells, weighs 3.9 grams. That's less than the weight of a nickel. And it's important to keep the weight down. And there's a comparison of it next to a battery there. The schematics, this is pretty washed out, but the schematic is pretty simple. There's 3 main parts: a transmitter, a GPS, and a processor. There's only about 11 or 12 total parts on that board, but it is a doozy to build. We don't want to go off starting in World War III, because when we let this balloon go, you don't know where it's going to go. We fly over Iraq, we fly over Iran, we fly over a lot of places. And we don't want to start World War III. Now, so there's a thing, and there's some laws where we can't fly, we can't transmit over certain countries. We can't transmit over the UK or Yemen or North Korea. And I've got little boxes there. So what we do in our software in this tracker is we do what we call geofencing. And we tell that tracker, if I'm in this part of the world, based on my GPS, don't transmit. So that's how we don't start a war right there. You know, I was going to mention at the beginning of the thing here to keep you guys interested that we were going to talk about astronauts and ants tonight. You know, an ant, the little bug that crawls, you know, astronauts and ants. So I'll get to the ants in a minute, and you'll be surprised about the ants. My friend, astronaut Doug Wheelock, and I met him through ham radio. Ham radio is great, man. And this is me and my friend Doug Wheelock, astronaut Doug Wheelock, at Dayton the year before last, the last one ahead, you know. And this is a balloon launch that Bill Brown does up there every year. It's kind of like a balloon race. And different people launch their, you know, we had 4 balloons. I think the Dayton Amateur Radio Club launched 3, and I launched 1, or I had Doug launch 1. It was a race. So I thought, what's the best way to really be successful in getting this balloon in this race and winning is to get an astronaut to launch it for you. So I took Doug outside, and we launched, and poor Doug, I mean, astronaut, I mean, he's a master at everything. He crashed it twice. Everybody else has took off, but I'm going to, here's just a short one here. We'll show you what it looks like to launch one. So there goes one. That's just a little silver party balloon. That's one of the cheap $4 balloons that can fly. All right, so that was one of them. It took off fine. The second, and well, we had some terrible wind. If you look at that, the wind was just tearing those balloons to pieces. Again, those balloons are not very full. You can kind of tell by looking at how empty they are. There goes the second one there. Bill told astronaut Wheelock, you got to run with it. Well, he's an astronaut. I just said astronauts don't run, man. Yeah. So, and here we go. We're fixing to launch here, Doug, and that wind is just really bad. So Doug is fixing to launch here. Here's his first attempt. And these have helium in it. And we're flying a sky tracker from Bill Brown. So here he goes. It looks pretty good. Looks like it's pretty good. It's got some lift. Oh, it took a kamikaze dive right there, and it wrapped around an RV mirror. So we went and got the thing, and we're going to do launch number 2. So here he is, astronaut Wheelock. He says, man, Tom, I feel like I let you down, man. yeah, I'm so sorry. I said, not a problem, not a problem. We'll launch again, launch again. So here we go. So Doug's going to launch it again. He's getting back to the launch position here, and he's going to let it go. And this is kind of interesting. I thought we lost it for good on this one, but here he goes. He's fixing to launch here. I think Bill said you got to run with it, and he didn't like to hear that, I don't think. Okay, here we go. All right. Here we go. All right, here we go. All right, so it's kind of low. Is it going to go up? It's going up a little, going up. You look at Doug, he's saying up, 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 up. And he says, oh no, it wrapped around a power line. So it wrapped around a power line, but then it unwrapped and it took off. So that's what you get for, I guess these astronauts don't really train that much in launching balloons like this. We'll have to teach them. Our first launch was a single 36-inch Mylar balloon. That's Bill Brown right there in the 36-inch balloon, and with helium. And it made it all the way to Japan. And, that's pretty typical. Some might make it, most don't. I found that in my findings are that if you want to send a balloon around the world, you're going to have to launch 10 times. And within 10 times, you're going to make it once. So this was our first launch, single 36-inch Mylar. And we launched it. And it made it all the way to Japan, and then it went down. Now, we get very serious about our balloon launches now. I mean, this is a big deal here. We made 14,000 miles in 14 days. We were doing really well. But then we hit a storm right off the coast of Japan, and I watched the altimeter, watched it go down, 30,000, 25, 24, 19. I watched it go down. So it's kind of sad, but, our commitment was we're going to keep going with our balloons there. We launched another set of smaller balloons, the party balloons, and this time it was 2 of those silver balloons taped together. And it made it to Poland, and here's a Polish ham radio club that actually rescued it for us. It was up in the top of a tree about 100 feet in the air, and these guys in Poland actually got it down for us, so they rescued it. We flew it from here to, we should have put a ladder or something in here, airmail. So they were nice enough to recover it for us. This is our best flight we flew. This is W5KUB-18. We launched number 23 today. This one went around the Earth 3.5 times. It actually went down in the Norwegian Sea between Greenland and Norway. But this is one of the tracks that you can follow the balloon on, and this is an interesting path. In fact, if you look at that, on our third lap, we were just about ready to complete our third lap, and it turned north. 20 miles from the finish line, for the third lap, it turns north, and it heads up through the North Pole and up in the Arctic and through Alaska, and then it came back, and then it went on over. So that added about a week to, we knew we were going to be celebrating the third lap tonight, but it took a week to get there. Here's a typical launch of our big balloon, the SBS 13 balloon. That's what our tracker looked like. This one went around the world 3.5 times. It was a solar panel, and if you look closely, those are drinking straws that are taped under it. So there were drinking straws taped under it. The little tracker was taped under it. Ed's fixing to let the balloon go there. And this is a very typical launch. And we fly this balloon all the time now because it has the best chance of making it around the world and also staying up much longer. I think the record on this balloon is one of these has been able to stay up 735 days. So it's fixing to let it go right there. Again, look at the bubble in the end. That's all the hydrogen that's in there. And we heat seal the bottom. And we always use hydrogen gas to get more lift. We'll get 3,000 feet more lift with hydrogen gas than we get with helium gas. And if you use helium party gas, you're going to even get less. But helium party gas is a good alternative. You can fly. So it just lets it go. It's going to head on up 17 feet below that. We got our tracker, and it's going to be hanging right below it. And below that's the other half of the antenna. So there it is. It's gone. Here, just to tell you what you can do with this thing. For instance, you're probably very familiar with the hurricane models that you see on TV. The weather shows you these hurricane models. And they might show you 10 different models, and they all kind of take the same way. Well, if you look at this picture here, that's exactly what this is. This is a NOAA prediction for our balloon. And if you see the red and the green and the blue there, those are prediction dots in timing, where that balloon is going to be at the next 12 hours, 24 hours, 72 hours. And I tell you, that balloon just about follows. It just about follows that pretty perfectly there. So it's a good indication. And that's on one of the websites. You were talking about websites and things tonight. That's one of the websites we use to track, and we'll talk a little about that in a few minutes. You know, if you launch on, will it make it around the Earth? You know, what will it take to make it around the Earth? And there's, 6 or 7 things that you got to have. First, you got to make it light. Then, I don't care how light you make it, you got to make it even lighter. And then the winter months are the best chance to fly it, just because right now, all the storms are below the equator. Summertime, all those big storms move up above the equator, and storms bring these balloons down. Even though we're flying, and the reason we're flying this balloon is to get that 45,000 feet. Now, that's to get us over some storms. Some of these storms are easily, 30,000 feet, cloud tops, 35, 40. So we want to try to fly over them. The smaller balloons that I mentioned earlier are going to fly so close down to the top of those storms that they're going to get sucked down if they get a storm in the path. So we try to fly over the storm. So fly as high as we can, launch in great weather. You got to have good weather. These balloons, when this balloon takes off, and when we launched today, it had 7 grams of lift. That's all, 7 grams of lift. That's just a couple pennies worth of lift. So, and we've done this before, and we learned the hard way. If you launch and it's cloudy up there, dark clouds, it gets up there, it gets moisture or some raindrops on it, and it's going to come down. It won't stay up at all. Just a few raindrops. Hey, I don't know if I can say this, but if a bird poops on it, it's going to come down. So don't skip in design, and you got to think about mechanical strength. Make sure all that stuff will hold together up there. You're going to get into winds of, 150, 200 miles an hour. Now, it's not going to be like you're in a hurricane or something like that. When we're flying at 150 miles an hour, everything is pretty much in relation to each other, like it's not moving. I mean, the whole thing is moving at that speed. It's not just whipping around or anything like that. So, but you got to design where you don't want it coming apart. You got to think about temperatures like minus 40 degrees Celsius. Temperatures will contract or expand solder joints. You want to make sure you don't have, cold solder joints, bad solder joints. Don't leave wires hanging out where if they move back and forth, they're going to break off, So don't skip in think about all those things. And then the last 2 important things are Mother Nature has to be on your side if this thing's going to make it around the world. And then the last thing is you have to have a miracle happen to get it around the world. So, our findings are 1 in 10 balloons is going to make it around the world. And our number 9 made it. Number 9 made it. Looking at the predictions there, here's some of the predictions. Sometimes we take a detour, and the one at the top left there was out in the Pacific. And oh man, I thought we were never going to get out of the Pacific. That right there took about 2 weeks to get across the ocean just because we were going in circles out there. And then you can see the one at the top right there. That's the one where we went way up into the Arctic Circle. It may look crude. That was Dash 18. That's the one that went around the world 3.5 times, and it stayed up 72 days. It's just that was a flexible solar panel. You can see the little drinking straws that I have fastened to the bottom there. And if you look closely to the center, you see the tracker kind of sticking out the end there. taped on the bottom. And those are actually the antennas, the number 36 wire. There's the bottom half, and there's the top half with the string in it. And the top half is attached to the string as we tie it to the balloon. So that's what we, that was a very successful flight. We're trying to break that record right now. There we are in the garage there, filling it with some hydrogen, and we have some weight scales, just like your typical drug user would use. We measure everything down to the gram. In fact, this morning, we got about 2 grams too much hydrogen in our balloons, so we had to squeeze out about, we don't like doing that, but we had to squeeze out about 2 grams of lift there. APRS, or Whisper, how do we track this thing? Man, we got great tracking, let me tell you. There's 2 methods you can use. One is APRS, and you're probably familiar with APRS. It's very good. It gives you things like your altitude, your location, your speed, but it's limited to where there's APRS. And of course, in the United States, we have APRS about everywhere. In Europe, there's some APRS. But our problem was, which I didn't like, when we fly these balloons, and they're going to cross the ocean. There is no APRS across the ocean. And if it takes you 4 days to get across the ocean, you don't know if it's flying or if it's come down. So, and then when you get to Africa, Middle East, top of India, there's really no APRS over there. So again, there's another 10 days that you might not even know if it's flying or where it is until it pops back up on the radar later. Whisper, you guys are probably familiar with Whisper. It's basically plots on a map, where you are. Basically, Whisper plots a 4-digit grid square. So if you use just basic Whisper, it's going to say, okay, this balloon is right in the center of a box, 200 miles by 300 miles. I mean, that's not great, but at least you know, is it over the ocean? Is it over Africa? So 200 by 300 miles. So that's not really good. We wanted to do better than that. So with a modified Whisper transmission, by sending a second set of data, we can get things back like altitude, speed, location, voltage, and we get it down to a 6-digit grid square. We get it down to a box that's 2 miles by 3, so that's pretty accurate. So that's really good. Plus Whisper, I mean, your APRS has got a range up there that high. It's got a range of a couple 100 miles. Whisper, our little 10 milliwatt tracker has a range of like 9,000 miles, 9,000. So I don't care if you're over Africa or India or ocean, we're going to know where it is. So that's the reason we use this modified Whisper. And I'll talk a little more about that. Here we go. This is a Whisper map. You can see there's our tracker right in the center over the ocean. And it says, hey, we're over the ocean. So if you just drew you a little 200 mile by 300 mile box, that's where we are right there. But you can see we had plenty of people picking it up, reporting it in Europe and also in the United States. So that's good. That's good. Here's how we get all that extra data that we do. So you take the balloon and we take Whisper and we transmit a second set of call letters. The first set we send is called W5KUB, and it sends a grid square, Echo Mike 55, a 4-digit grid square. So that sends it. It goes into a receiver on the ground. They put it into the Whisper database, and anybody can look it up and know that I'm within Echo Mike 55. Now, with this modified Whisper transmission, we send a second call letters, which starts with something like a 1 or a Q. And the one we're flying right now is a Q7. There is no country in the world that has a Q7 call. So we send a different data string like QX7XXX down to Whisper, and it goes in the database. And what those X's are, the QX7, that first X, that's the number of satellites. And then QX7XXX, the first X may be voltage. And then the second two X's would be, they would be the fourth, I mean, it'd be the fifth and sixth indicator of your grid square, which would give you EchoMike 55 plus dB. So you get six, you put it together, you get 6 digit grid square, and now you're down to a 2 mile square. So the balloon transmits these 2 transmissions. It's picked up by Whisper. Whisper then sends it to the internet. They send it to the Whisper database. And then on the ground, we have a computer running with a Python script. And it pulls that information from the database. It pulls it in and says, okay, I got a QA7 ABC. Well, that A, that's 12 satellites. And then that B is 3.7 volts. The C is D, and then the next letter is B, like DB for your 6-digit grid square. So then it takes that information from a spreadsheet and it matches those letters to a spreadsheet in a database, and then it sends it to APRS. Then we send it to APRS, and then it's just like you were on APRS. You could pull up your call on APRS, and you're going to see altitude, speed, course, voltage, all those things. So that's kind of a trick we do to get that extra data, and it is really sharp. And this balloon just don't go anywhere. You'll know where it is. Every 10 minutes, we get a report where this balloon is. Some great websites to help you predict your flight is windy.com and Ventusky. And I want to show you a couple of these. You know, with our GPS and our trackers, we know exactly where we are, and we know our altitude. So if we know all that, let me see if I can go to, I'm going to go to Ventusky here. I'll go to Windy. Here's Windy right now. So this is our website. It's called windy.com. Now, we know our exact position and we know our altitude. So if you look at this over here on the right side, you set the altitude. So I'll set the altitude there at say 42,000 feet. And then we know our position is here. And look, our position right here says right now, you should be moving at 97 miles per hour. So that's part of a jet stream. So if we move that around right there, there's 100 miles an hour right there. As long as we're traveling right through there, 100 miles an hour. When we hit the blue, we're going to slow down. There's 80, 60, 40. And then we're going to come on across here, and we're going to hit back up to 100 miles an hour. So that's kind of a great website that will help you. That's called Ventusky. It will also show you storms. If I click on thunderstorms, let's see. Okay, if I click on thunderstorms, if you look at this, you'll see that most all the storms right now are south of the equator. North of the equator is pretty clear right there. And then there's another one called Ventusky. Ventusky, look at this. Ventusky is really neat, man. You know right where we are. Right now, our balloon is somewhere over South Carolina. It's nighttime and we don't know exactly where it is. But we're right in here. And look at that, 135 miles an hour right now. And this is the direction we're going right here. We're going to follow the air here. And we're going to follow the air, and we can see exactly where it's going to go. We generally always cross at the Straits of Gibraltar. We always go through right there below Spain at the Straits of Gibraltar. We'll go across Libya and then across the Middle East here. We'll hit Iraq, Iran. And then we get into the stands, the Kyrgyzstan and places like that over here. This is kind of a tough area here to receive from, but you can also tune in with SDR receivers, you know, like Kiwi receivers. You can take your computer and go online to a Kiwi receiver, say in Russia, and you can listen for it, and you can hear it and collect the data and put it into the database. So that's kind of cool the way we can see where it is. Those are helpful things. So, and it also shows cloud tops. For instance, here, here's a still picture. Right there, the cloud tops were 41,800 feet. We're flying at about 42,000, so it's getting pretty close there. Again, that's the speed. I just showed you a minute ago, the speed. we crashed in the Norwegian Sea on flight 18. That was his final resting place right there. Now, I'm going to talk about ants. You know, I mentioned astronauts and ants. You know, somebody asked us, how do we steer the balloon? Steer it. Well, you really don't steer it. But we said, well, we've got some highly trained ants. We put them through a year of training to steer this thing, and it kind of took on, and everybody started talking about the ants. And if you go on our Facebook page right now and follow the flights, they're asking about the ants and where they are, and they're wishing them good luck, and on and on and on. We even give out certificates there for people that follow the flight, copy the flight, pick it up on Whisper. We send out certificates, and these guys, these ants, were actually awarded different medals when they crossed the international date line. They got a medal when they, you know, various different things. So that's kind of cool, right there. We've had 13 flights this year, no casualties. We have a great first-class rescue team. This picture was made of our crew on flight 18 when they went down in the Norwegian Sea. But there they are there with a telephoto camera. When the plane went by, you can see all 3 crew members are doing okay there. The last flight we had, it crashed in China. We didn't know how we were going to get the ants out, but they were rescued there by Tibetan monks there. They rescued the crew of Flight 22. Here's some of your options here to, if you're interested in doing this. You can use hydrogen gas. There's some risk to that. It's cheaper than helium. Or you can use helium gas. Not hardly any risk to that. And typically most schools and places like that use the helium gas just to avoid any risk. Helium is a lot more expensive. Helium is a rare gas. You know, hydrogen is a gas that can be not recycled, but made, you know, by various different processes. Hydrogen is plentiful, whereas helium is not plentiful. It's kind of a rare gas. It comes out of the ground at some of the natural gas places, and it's caused by radioactive material near the gas, and that produces the helium. Now, helium is used in a lot of medical devices, and that's where most of it goes. So it's more expensive. We use hydrogen all the time. It gives us about 3,000 feet more lift. In our particular balloon, we can fly that balloon at 45,000 feet with hydrogen. If we put the helium in that, we would only fly at about 42,000 or something like that, 43,000 feet maybe. And you can't put more gas in to go higher. It doesn't work that way. Okay, so you can do you know, for the tracker. What are you gonna do for the tracker? A home built tracker? It's difficult. You saw the size of those parts. It's cheaper to build, but you really got to gear up. I mean, you need to buy a microscope. You need to buy special tools for soldering and for holding the parts and so forth. The pre-built trackers, they're ready to go. That's the way I would suggest people that are getting started, you know, to do that. You can fly the expensive balloons like what we're flying, the $180 balloons. I see SBS 13 balloons. Or you can fly some of the inexpensive $4 balloons. Now, these $4 balloons typically might last a week. There's one of them right now that has gone around the world 9 times. And that's a $4 balloon. It's gone around 9 times. So I won't say they can't do it. And even the big expensive balloon that I'm talking about here, I've seen them not last more than 1 or 2 days. So, you know, it's Mother Nature for sure. So hydrogen takes you higher. It's a little dangerous. We still have all of our eyebrows and all of our fingers after all this. We haven't had any problems with it at all. But if you want to use hydrogen, that's probably something there you might want to think about getting. Get you one of those suits right there. Okay, on this flight, we added some new things to this flight, this launch today. we added a CWID, and it can actually be heard if you tune down to 14092. You can hear it, and we had people today after launch even copying it up in Canada. And it's just a CWID. It's about 10 words a minute. You'll hear it. It transmits once, and it transmits on the minute every 1 minute, 11 minutes, 21 minutes, 31, 41, and 51. That's when it transmits. We also added a QRSS mode. QRSS, if you're a CW operator, you know QRS stands for go slow. Well, QRSS is very slow. It is, that is transmitted at about one word a minute, but that's because there's a program out there that, and I forget the name of the program, Alpo or something like that. I can get it for you guys, but it has a waterfall, and it will actually, and I got a video here to show you what it does. It actually will copy that QRSS, that slow CW, and it will actually put the dots and the dashes on the waterfall, and you'll be able to see the call sign in the waterfall. We were going to run a 100 milliwatt amplifier on this flight. We're only running 10 milliwatts. Again, 10 milliwatts is getting us 9,000 miles, but we were going to try to run 100 milliwatts. I wanted to try something different. I spent about 2 weeks pulling my hair out trying to get a 100 milliwatt amplifier working, and I'm having a lot of difficulty with it because we actually have a lot of voltage variations. We go from 3.8 volts down to 2.9 volts, and a lot of things going on there, and also the impedance matching of the antenna and so forth. So I've decided to put that off. So we are flying the CWID in a QRSS mode. I've got a tracking light on my website, w5kub.com. If you'll just go to Balloon at the upper menu, Balloon, and click on it, it'll bring you up to our tracking site, and you'll see some pictures. Let's see. Messed up. You'll see pictures and maybe of the launch, of building the thing. There's 3 buttons there you can click on that will take you to easy tracking. If you click on APRS button or the Hub button or the Whisper button, it'll take you right to tracking right there. It tells you how long we've been up in the air and so forth. So that's at w5kub.com. Click on Balloon, and there we'll go. Now, here we go. We're close to the end of our talk on this, but this is AMPS again. So we have a lot of interaction with the guys up here. All right. So I do want to thank Edward, Y03 ICT, for encouraging me to build that little bitty tracker. He really helped me. And of course, Bill Brown is the master of high altitude balloons. Bill's been launching balloons for 30 years and has probably made 1,000 launches. And he's been the one behind the Python script and the firmware and so forth. Here is here's the QRSS. Let's see if I can make this play here. You can hear here, Bill tuned in today, the CWID, and he copied the QRSS. All right, you watch this right here. Let's see, I got to turn it up. I got to give you some. If you watch this, this is Argo, ARGO, it's free software. This will actually copy that 1 word per minute CW that we're transmitting, and it will put in a visual form. Look at this. If you look at coming across the screen, you see a W there, da-da-da. And then you see the 5, did-it-did-it-it. And then the KUB, how you like it? It's actually decoding that, and it's actually putting it on a screen. That's called Argo. And that's kind of a neat little program that, again, it will decode stuff just like Whisper does. All right. So that was pretty much what I wanted to talk to you about on about the balloons. the Pico Balloons. I do want to mention to you just very quickly about our show and invite you guys to be a part of it. And because our show does these type projects, and this project is an ongoing one for the shows. You may have recognized, I don't know if you saw Tim Allen, he a short appearance there. We've taken our show out to Hollywood, and I met Tim Allen. We got to break the news on our show that Tim got his license. We've got Riley Hollingsworth from retired from the FCC, as a co-host, and Katie, and it's probably one of the fastest growing ham shows out there. We would like to invite all you guys to it. It's on Tuesday nights at 9 p.m. Eastern Time. Just go to W5KUB on YouTube. Just go to YouTube and key in W5KUB. Or you can go to my website, W5KUB.com, and you can click on live video and chat. And, right now we're giving away an HF antenna to somebody every week for the next 8 weeks. Our show has been going now for about a little over 6.5 years, well, almost 7 years now, actually. And for 18 years, we webcasted major events like Hamvention, and we would actually do a 50-hour marathon stream, and we would give away about $10,000 in prizes to people watching that couldn't, come to Hamfest. And so we got a big following. We've been watched in 150 countries. Our show also is broadcast on Thursday afternoons on famous international shortwave station WBCQ on 7490. Our entire show is repeated on shortwave. We have an audio podcast. If you're driving across country and you want to download it, we've got nearly every podcast carrier out there, from iTunes to any of these guys, Google Play, any of these guys. You can get our podcast. And we've got phone lines in about 65 countries. People typically from Australia call into the show at night. So we just like to invite you to the show. And also, let me just one more thing. Our Facebook group, we have a ham radio Facebook group that has over 11,000 hams in it. And just on Facebook, just search for W5KUB, and that's it. It's actually Amateur Radio Roundtable, but you can search for W5KUB, and would love to have you join us there. It follows the show. It follows all of our balloon launches and all the different projects and things that we've got going on. So I hope I didn't take too long. I'm just so thankful, and thank you so much for asking me to come tonight.
It's about 9 o'clock, so I just want to say thank you so much, Tom. That was an excellent presentation. That's very fascinating. I know we have a few people here who actually are looking to do some balloon stuff as well, so sure you'll hear more from Vienna Wireless in general. So, but thank you so much for joining us. If you are so inclined, we're going to officially close the meeting, but if you are inclined to stick around, I think some people would probably be glad to talk to you a little bit more.
Yeah, I'll stick around. I want to invite everybody out there again. Join that Facebook group, W5KUB, and join our Tuesday night show every Tuesday night, 9 o'clock. I know that's late for you guys on the East Coast, but that's 6 o'clock for the guys on the West Coast. So anyway, join us, W5KUB. Look us up.